everyone. In the previous video, we have discussed about nucleophilic substitution reactions of aryl halides. We know that these aryl halides are less reactive towards this nucleophilic substitution reaction as compared to alkyl halides. But we know that if electron withdrawing group is present at ortho position or at para position of aryl halides, then it may undergo this nucleophilic reaction little easily. So now let us understand this with some examples. Here I have already written certain reactions and we are just going to write down the product of those reactants. So here we will begin with chlorobenzene and we want to carry out SN reaction of chlorobenzene. So what happens in SN reaction of aryl halides? This halogen will be replaced by a nucleophile. So in this case OH minus is going to be our nucleophile. So now look at the reaction conditions. It says OH minus 623 Kelvin, 300 atmosphere and H3O plus. This H3O plus is nothing but H2O plus H plus means water plus H plus and H plus is nothing but acid. So here H3O plus hydronium ions will indicate that the condition of the reaction has to be acidic condition. So now let us begin with chlorobenzene. What is going to happen? This Cl will be replaced by OH minus. So we have to do only one simple thing. We will remove chlorine and instead of chlorine we will put OH. So the product formed in this reaction is phenol. If you look at the second reaction, here NO2 nitro group is electron withdrawing group which is present at the para position. If this position of the chlorine is first position, you go from either side. Position of nitro group is fourth position. So therefore we call 1,4 type of position as para position. So name of the compound becomes para nitrochlorobenzene. This was our chlorobenzene. We have added NO2 group over here at para position. So therefore the name becomes para, which stands like P stands for para position, nitro because nitro group is present at para position, and chlorobenzene, our main structure was chlorobenzene. So the name of the compound becomes para nitrochlorobenzene. Now what is going to happen over here? This Cl will be replaced by OH minus. So बस एक ही काम करना है, Cl को हटा के OH लगा देना है. But we also have NO2 group at para position. We have copied the entire structure as it is. We have just removed Cl and instead of Cl we have put OH group, hydroxyl group. Now here the structure that we have started with para nitrochlorobenzene. If we start with chlorobenzene we get phenol. So if we have at para position, if we have nitro group, then in the product also we have nitro group at the para position. So name of the product will become para nitrophenol. This was phenol. What is added over here is this NO2 group at para position. So therefore this phenol will change in, like the name phenol will change into para nitrophenol. So now let us go to the next reaction. Here also we are going to do the same thing. We will remove Cl and instead of Cl we will put OH minus. nitro group is present at two positions, here at ortho position and here at para position also. So if this is our first position, this is second, third and fourth. So we can say that nitro group is present at second position and fourth position. So therefore name of the compound will be 2,4 dinitro. Two nitro groups are present, so therefore dinitrochlorobenzene. So similarly we are going to write down the name of the product. It is going to be 2,4 dinitro, which is common because here also at the second position and at the fourth position we have nitro group. So the name of the product is going to be 2,4 dinitrophenol. Now the last reaction, here also we will do the same thing. We will remove Cl and instead of Cl we will put OH. So here we have started with 2,4,6 trinitrochlorobenzene. This is our first position. I will go from this side, second, third, fourth, fifth and sixth. So where is nitro group present? It is present at second position, at fourth position and at sixth position. So name of the reactant becomes 2,4,6 trinitro because three nitro groups are present, trinitrochlorobenzene. So the name of the product has to be 2,4,6 trinitrophenol. Now till this it was really easy. Now what is very important to understand is the reaction conditions, which you should not forget while writing the answers in the question paper. So here if you look at the reaction conditions, the reaction conditions are extreme, like we require high temperature 623 Kelvin and 300 atmospheric pressure, so it is going to be an extreme condition. Now look at the second reaction. Here we have one electron withdrawing group present at para position. One electron withdrawing group at para position. Now the conditions of the reactions have become mild. Like here we require 623 Kelvin, but if we have electron withdrawing group at para position, we require 443 Kelvin, which is that temperature is little lower than what we were doing, what we required in case of chlorobenzene. Now let us go to the next example. Here we have two electron withdrawing groups, not just one, we have two electron withdrawing groups, one at the second position or we can say ortho position and next one is at the para position or fourth position. So now the conditions have even gone milder than the previous reaction. Then let us go to the next reaction. Here we have three nitro groups at the para position, and at both the nitro position. And here what we require is H2O and we need to warm the reactant with H2O and still we are getting the product. So that means we can say that as the number of electron withdrawing groups are increased. Okay, here there was no electron withdrawing group, one electron withdrawing group, two electron withdrawing groups and three electron withdrawing groups. So as the number of electron withdrawing group go on increasing, reaction becomes little easier to carry out, or we can say reaction becomes little active, or the substrate reactant becomes little active towards nucleophilic substitution reaction. But now tell me, if this nitro group is present at meta position, over here if there is nitro group present, will it affect the rate of the reaction or will it affect the reactivity of the reactant? No, because If it is present on the meta position, then it is not going to affect at all, because in the resonance structures that we have studied in the previous video, there was no negative charge located on meta position. Negative charge was located only at ortho and para position. So therefore it is necessary that these electron withdrawing groups should be present at ortho and para position. Now let us understand why it is important for the electron withdrawing group to be present only at ortho and para position with one example. I have drawn the structure of chlorobenzene, and let us put our electron withdrawing group at para position. Imagine that we have nitro group at para position. Now the structure of NO2 group is in reality is like this. N double bond O and single bond O. Now there is going to be a positive charge on nitrogen and negative charge on this oxygen. So the reason is, we know that valency of oxygen is 2, that means there has to be 2 bonds around oxygen. So this oxygen has 2 bonds, it's proper, and along with these 2 bonds there are 2 lone pairs of electrons. There are 4 electrons, that means there are 2 lone pairs of electrons. But if we have oxygen around which there is only a single bond, then it will have 3 lone pairs of electrons. Like this, okay? So now since there are 2 electrons extra, ideally सिर्फ 2 lone pair ही होना चाहिए, but here we have 3 lone pairs, that means we have 2 extra electrons. So whenever we have such a situation, there is going to be a negative charge on the oxygen atom and positive charge on the nitrogen atom, because in normal case, say for example NH3, in case of NH3, there is a lone pair of electrons on nitrogen, but on this particular nitrogen there is no lone pairs of electrons. So we can say there are 2 electrons less on the nitrogen. 1 lone pair of electron is less on the nitrogen. So since it has got less number of electrons, less number of lone pairs, it will carry a positive charge. So this is what you need to remember. N will have positive charge. This singly bonded oxygen will have negative charge, and this doubly bonded oxygen will have no charge. Now this chlorine atom will also have 3 lone pairs of electrons, as we have discussed in the previous video. Now what is going to happen over here is attack of nucleophile. So if there, imagine that there is a nucleophile OH minus. This OH minus will attack this carbon atom like this. After the attack, there will be a bond formation between this carbon and oxygen. The first step over this step over here is the slow step. So now there has been a formation of bond between this oxygen and this carbon, but this carbon cannot be pentavalent. So to avoid that, these pairs of electrons from the pi bond, from the double bond, will shift to this carbon atom. So after shifting of the electrons to this carbon atom, carbon will bear a negative charge over here. and remaining 2 bonds will remain as it is. But as we have discussed in the previous video, this electrons has to go in the conjugation of the entire structure. So for that reason, again this electrons will shift over here. Let me draw it little better. So these electrons will shift over here and there will be a formation of double bond between these 2 carbon atoms, and again these 2 electrons will shift on the 4th carbon atom to which the electron withdrawing group is attached. So after shift of the electrons over here, there is going to be a double bond, and on this carbon atom a negative charge will be located. Now if there was no NO2 group present over here, the conjugation have moved in the remaining bonds of the benzene ring. But since we have this NO2 electron withdrawing group present at the para position, these electrons will be withdrawn by the nitro group like this. So instead of shift of these electrons to form another double bond between carbon atoms, these electrons will shift over here like this. So this single bond will now turn into a double bond. Double bond L. So again these electrons which were present between double bond of the nitrogen and oxygen, pi bond of the nitrogen and oxygen, will shift on oxygen. So now we have single bond. 2 lone pairs of electrons are already present on oxygen. 2 lone pairs were already present. On top of that, due to shift of the electrons on the oxygen, 2 more electrons are now located on oxygen. And this oxygen will remain as it is. Now both the oxygens are of the same type. Correct? Here also we have singly bonded oxygen with 3 lone pairs of electrons, singly bonded oxygen with 3 lone pairs of electrons. So again for the stability of electrons, a lone pair of electrons either from this oxygen or from another oxygen, कोई भी oxygen में से दिखा सकते हो, will shift back to form a double bond with nitrogen. So let us assume that these 2 electrons shift like this. They will again form a double bond. But when the double bond is formed between oxygen and nitrogen, this pi bond has to again shift back over here. If this happens, there is going to be again a negative charge on the 4th carbon atom. So I am drawing the next structure over here. these two electrons are already shifted over here. So again there will be a formation of double bond between oxygen and nitrogen. These electrons are again now shifted. These electrons which were present over here are again shifted to the fourth carbon atom. So this fourth carbon atom will bear a negative charge. Again there will be a shifting of electrons, shift of the pi bond as we have discussed earlier. Like this, and now the negative charge will be located on this carbon. So this single bond, due to shift of the electrons from this carbon to form a bond, there will be a double bond. On this carbon there will be a negative charge. Now every time I am drawing lone pairs of electrons here on oxygen, but I am not drawing lone pairs of electrons on chlorine, because right now they are not required in the resonance, or right now they are not required in the conjugation. Doesn't mean that these lone pairs are absent and not participating at all, but right now we are not looking at them, so therefore I am not drawing the lone pairs of electrons on chlorine atom. So now again there will be shift of electrons. So electrons on this carbon atom will shift here to form a double bond again. But when it is shifting over here, this carbon atom again may become pentavalent, which is not possible, which should not happen. So therefore, now chlorine will leave along with its electron pair. So in the last step, in this last structure, which is the first step of the reaction, Cl- will leave. So due to shift of electrons, there is a formation of double bond. Everything else will remain as it is. And Cl is already gone. So now if you observe, our reactant had chlorine, but our product has OH group. So we can say that this Cl is successfully replaced by nucleophile OH minus. Now imagine that if there was no nitro group present at para position, then the electrons may not have conjugated more like this. Here we have so many resonance structures. 1, 2, 3, 4 and 5. 5 resonance structure. But if there was no nitro group, ये वाला स्टेप होता ही नहीं, ये वाला स्टेप एग्जिस्ट ही नहीं करता. सेकेंड एंड थर्ड स्ट्रक्चर तो होता ही नहीं रेजोनेंस में. सो इसीलिए ड्यू टू प्रेजेंस ऑफ नाइट्रो ग्रुप देयर आर मोर नंबर ऑफ resonance structure than what we expect if there is no NO2 group. अगर NO2 group नहीं होता para position पे तो number of resonance structures कम होते, but NO2 group para position पे है, इसीलिए ये second and third या फिर 4 जो भी रहेगा, second, third, 4, ये सारे resonance structures possible है. So we can say due to presence of electron withdrawing group there are more number of resonance structures, and we have learned in 11th standard that more the number of resonance structures, more is the stability. जितना ज़्यादा resonance होगा उतना ज़्यादा stable compound मिलेगा. So due to more structure of resonance, we say that this substrate, this reactant becomes more active towards nucleophilic substitution reaction. But now imagine that the nitro group is present at meta position, ऑर्थो पे होगा तो भी you can get the similar kind of structures. I want you to try all these structures on paper because ये सारे structures बस ऐसे बुक में पढ़ के या फिर ब्लैक बोर्ड पे देख के नहीं आते, इसके लिए बहुत प्रैक्टिस करना पड़ता है. So I want you all to practice this type of resonance structures first by taking nitro group at para positions and then by taking nitro group at ortho position. But अभी अगर यही structures तुम मेटा पोजीशन पे NO2 ग्रुप लेके करेंगे तो there may not be so many structures. There are not so many structures when NO2 group is present at meta position. Why? Because if you observe, this negative charge is present at ortho position. This is the position of chlorine and this is the ortho position. Then in the next structure, it is present at para position and again in this structure, this negative charge is again present at ortho position because ये दोनों भी ortho है, दोनों भी मेटा है और ये para है. So the negative charge is located only at ortho and para position and no negative charge is located at meta position. So अगर meta position पे negative charge है ही नहीं तो वो वाला ग्रुप किसको विड्रॉ करेगा? उधर इलेक्ट्रॉन्स है ही नहीं तो इलेक्ट्रॉन विड्रॉइंग ग्रुप उधर प्रेजेंट होने का कोई मतलब ही नहीं बनता बिकॉज उसके पास अगर नाइट्रो ग्रुप इधर होता एट मेटा पोजीशन बट फिर भी उसके पास इलेक्ट्रॉन विड्रॉ करने के लिए इलेक्ट्रॉन्स अवेलेबल ही नहीं है. सो देयरफॉर वी रिक्वायर इलेक्ट्रॉन विड्रॉइंग ग्रुप ओनली एट ऑर्थो एंड पैरा पोजीशन एंड it's okay or we can say it is not required to be present at meta position. If it is present then it is not so useful for the SN reaction. Now I want you all to practice all these structures, then only you will be able to draw these structures. सिर्फ देखने से नहीं होगा. So please do practice all the resonance structures. Thank you so much for watching.